Welcome students. Today's video is on solving systems of equations by elimination, but this is the harder case when we have to use multiplication or division. These are the steps for the elimination method. Number one, we need to make sure both of our equations are stacked on top of each other correctly. So x is on top of x's and y is on top of y's. Step two, identify which x or y you would like to eliminate with the matching coefficients. If they match, you're going to add or subtract. If there's not a pair of matching, then we're going to use multiplication or division to create one, like we're going to do today. Then eventually, you solve the one-step equation, you sub it in, and you'll find your second solution. So let's start with this first example. Looking at my x's, I see 4 and 3. Looking at my y's, I have 9 and 1. So if I'm looking for one that I could easily make match, I could multiply the entire bottom equation by 9. Doing that, I'm going to rewrite the whole problem. So I will have 4x minus 9y equals negative 11 on top, just like before. And now I have to do 9 times 3x, which will give me 27x. 9 times negative y is negative 9y. And 9 times 9 will give me 81. Now looking at this, I see top to bottom my y's are matching, which means I'll subtract. 4x minus 27x is negative 23x. 9y minus 9y. Negative 11 minus 81 will give me negative 92. Now I have to solve the one step by dividing both by negative 23. And I now know x is equal to positive 4. Since I know my x, I can plug it back into either of the two original equations. So I'll just plug it into the top. So that would be 4 times 4 minus 9y equals negative 11. 4 times 4 is 16 minus 9y is negative 11. I can subtract 16 from both sides. Negative 9y is equal to negative 27. If I divide both by 9, I get y equals 3. And I now have the ordered pair solution for 3. Looking at this next one, comparing x's and y's, I see for my x's I have 2 and negative 5. For my y's I have negative 3 and negative 9. I know that 3 can easily turn into 9. So I'm going to multiply the entire top equation by 3. If I do that, I'll get 6x minus 9y equals negative 18 on top of negative 5x minus 9y equals 15. Pause the video and solve it from here. Unpause when you're ready to check. If you solved correctly, you would have subtracted. You got to 11x equals negative 33. You solved x for negative 3. Then you plugged it back into either the top or bottom equation, and you figured out that your y was 0. So you got the ordered pair negative 3, 0. Try this next one on your own. Unpause when you're ready to check. Looking at these two, I would notice that my y's can easily both become 8. So I would multiply the whole bottom equation by 4. That'll give me 6x plus 8y equals 26 on top still. And then that bottom one will become negative 28x plus 8y equals negative 76. Now since these both match, I'll subtract. 6x minus negative 28x is going to give me a positive 34x. 26 minus negative 76 is positive 102. I would divide both by 34. And now I know x is equal to 3. If I plug that back into one of the originals, I get 6 times 3 plus 8y equals 26. 6 times 3 is 18 plus 8y equals 26. I can subtract off 18. 8y is equal to 8, so y is 1. And I have an ordered pair of 3, 1. Solve using elimination. On this one, I see that 10 and 20 are probably the best ones to work with. So I'm going to multiply the whole bottom equation by 2. If I do that, the top stays the same with negative 20x plus 6y equals negative 6. But the bottom will get multiplied by 2, which will turn into negative 20x minus 8y equals 8. Now if I look at adding and subtracting, since they're both negatives, I'll subtract. So negative 20 minus negative 20 will cancel. 6 minus negative 8 will add together, and I will get 14y. Negative 6 minus 8 will become negative 14. Divide both by 14. Y is equal to negative 1. Now that y is negative 1, I can put that into one of my original equations. I'll choose the bottom. So negative 10x minus 4 times negative 1 equals 4. Negative 10x plus 4 equals 4. I can subtract 4 from both sides, and I get negative 10x equals 0. Divide by negative 10, and x equals 0. So I have an ordered pair of 0, negative 1. Solve by using elimination. If I look at this one, I can see that there's no x or y that's ready to go for me. So that means I'm going to have to multiply both the top and the bottom. I'll choose to work with my y's, so I'll multiply the entire top equation by 6 because of the 6y, and I'll multiply the entire bottom equation by 7 because of the 7y. This will get them to both 42y. So my top equation, once it's been multiplied, will be 42x plus 42y equals 0. My bottom equation is negative 63x minus 42y, and it's equal to positive 84. Looking at these, I see that I have a positive 42 and a negative 42. That means I get to add. So 42 plus negative 63 is negative 21x. My y's cancel, and this is equal to positive 84. I'll divide by a negative 21 and get x is equal to negative 4. Now I can plug that back into either of the two originals. I'll just do the top. So 7 times negative 4 plus 7y equals 0. 7 times negative 4 is negative 28 plus 7y equals 0. I can add 28 to both sides and get 7y is equal to 28. Divide by 7, and y is equal to 4. So I get the ordered pair negative 4, 4. This is another one where you're going to have to multiply the top and the bottom equation. Try this one and unpause when you're ready to check it. You could have either done your x's or your y's. I chose to use my x's, and I figured out that my answer was 5, negative 7. If your work doesn't match mine but your ordered pair does, that means that you solved it correctly. Thanks for watching.